Let's take a look at example 4 here. We have the absolute value of 2x minus 1 equals 7. Notice my absolute value is already by itself, so I don't have to isolate it. So what that tells me, inside my absolute value could be 7 or it could be negative 7. This is where we talk about those two cases, because the absolute value of negative 7 is 7. We never change what's inside the absolute value, so I make two cases. Case 1, 2x minus 1 equals 7, or case 2, 2x minus 1 equals the opposite of 7. Or negative 7. Now we solve that equation twice. First we do 2x minus 1 equals 7. So the opposite of subtracting 1, we're going to add 1. And 7 plus 1 is 8. So we get 2x. Sorry about that. 2x equals 8. Then we'll divide both sides by 2. X equals 4. Now in the other equation, we do the same steps, except we're going to have different numbers because we're starting at negative 7 instead of 7. So we add 1 to both sides. So we get 2x minus 1 or 2x, I should say. You bring down the 2x. Negative 1 plus 1, they cancel, so that's 0. Negative 7 plus 1 is negative 6. Divide both sides by 2. X equals negative 3. And we're supposed to graph this on a number line. So on your number line, make sure your number line has negative 3 and 4 on it. I go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. And since it's equal to, we just put a dot on each one. So put a dot on x equals 4, put a dot on x equals negative 3, and there's your solution. Now let's take a look at example 5 here. We got a problem. The absolute value is by itself, isn't it? But you can't have absolute value, can't have the distance be negative. So we got a problem here. There's nothing we can do that would make this true. There's no value on the left side that will give you an absolute value that's negative. So this would be a no solution. If you ever get the absolute value by itself and it equals to a negative, that's just not possible. Now we can take absolute value, we can apply it to a word problem or a manufacturing problem. Let's take a look at that on example 6. It says the average January temperature in a Northern California city is 1 degrees Fahrenheit. The actual January temperature for the city may be about 5 degrees warmer or colder. Write and solve an absolute value equation to find the maximum and minimum temperatures. So here's what I want you to think of when you're doing absolute value equations within a context of a word problem. That is, we're going to say it's the absolute value of x, your variable, minus what we say is your average, what you want it to be. That equals to the tolerance, which is how much it can be off by. Now on this problem, we want the temperature. It says the average temperature is 1. So we're going to say the absolute value of x minus 1 equals, now how many degrees can it be off? Well, reading the question, it can be off by as much as 5 degrees, so equals 5. Notice the absolute value symbol is by itself. So what we're going to do is we're going to split it up and we're going to say, oh, what's inside here could be 5 or it could be negative 5. So we say x minus 1 equals 5 or x minus 1 would equal negative 5. Now we'll solve each equation. So we'll add 1 to both sides. So x equals 6. Over here, we'll add 1 to both sides. X equals negative 4. So the actual temperature of the city can vary from -4 to 6 degrees Fahrenheit. I think they use Fahrenheit. Yeah, they use Fahrenheit, and that's what you have to do.